In this video, we'll look at NoSQL data storage. So a database is a collection of logically related data, including the metadata, which is also called the data that describes the data. So a database management system, also known as a DBMS, is a software system that enables a user to create, maintain, and query the database. Most DBMSs have facilities that make data access fast, reliable, and secure. Some examples of common DBMSs that are available would include like Oracle, MS Access, MySQL, MS SQL Server, Postgres, and there are many more. So a NoSQL database. So NoSQL can mean it's not SQL or not only SQL. So NoSQL is an approach to databases that represents a shift away from traditional relational database management systems, so RDMS. To define NoSQL, it is helpful to start by describing what is SQL, which is a query language used by RDBMSs, so relational database management systems. These relational databases rely on structured relationships between stored items, utilizing tables, columns, rows, or schemas to organize and retrieve the data. In contrast, NoSQL databases do not rely on these structures and use more flexible data models. An RDBMS have increasingly failed to meet the performance, scalability, and flexibility needs that next-generation data-intensive applications require. NoSQL databases have been adopted by mainstream enterprises. NoSQL is particularly useful for storing unstructured data, which is growing far more rapidly than structured data and does not fit the relational schemas of RDBMSs. Common types of unstructured data include user and session data, chat messaging and log data, time series data such as Internet of Things, and device data, and large objects such as videos and images. Several different varieties of NoSQL databases have been created to support specific needs and use cases. These fall into four main categories. Firstly, we start with the key value data stores. So key value NoSQL databases emphasize simplicity and are very useful in accelerating an application to support high-speed read and write processing of non-transactional data. So transactional data, to define that, consists of one or more actions on the database, each writing or reading from the database. So these transactions help maintain integrity of the data during the period that the transaction is completing. So in this case, with our NoSQL, we're talking about processing of non-transactional data, which is an important point to make between the use of an RDBMS and a NoSQL database. So stored values can be of any type of binary object, of text, video, JSON documents, etc., and are accessed via a key. The application has complete control over what is stored in the value, making this the most flexible of the NoSQL models. Data is partitioned and replicated across a cluster to get scalability and availability. For this reason, key value stores often do not support transactions. However, they are highly effective at scaling applications that deal with high velocity, non-transactional data. Document stores. So a document database typically stores self-describing JSON, XML, or BSON data, so binary JSON documents. They are similar to key value stores, but in this case, a value is a single document that stores all data related to a specific key. Popular fields in the document can be indexed to provide fast retrieval without knowing the key. Each document can have the same or different structure. And our third type is the graph stores. So a graph database uses graph structures to store, map, and query relationships. They provide index-free adjacency so that adjacent elements are linked together without using an index. Wide column stores. So wide column NoSQL database stores data in tables with rows and columns similar to your RDBMS. but names and formats of columns can vary from row to row across the table. Wide column databases group columns of related data together. A query can retrieve related data in a single operation because only the columns associated with the query are retrieved. In an RDBMS, the data would be in different rows, stored in different places on the disk, requiring multiple disk operations for retrieval. And lastly, we can actually have a combination of all four types and picking the best of each option. So benefits of a NoSQL. Firstly, scalability. So NoSQL databases use a horizontal scale-out methodology. So this is just by simply adding more machines rather than making the machines bigger. This allows us to add or reduce capacity quickly and non-disruptively with commodity hardware. So this eliminates the tremendous cost and complexity of manual sharding. Manual sharding is the process of breaking up a database content across multiple server instances. So by reducing the complexity, because we don't have to create multiple, or we don't have to break up our databases and manage that, we can replicate out the entire database across cheap commodity hardware, makes scalability a lot easier than an RDBMS. So performance. So by simply adding commodity resources, enterprises can increase performance with NoSQL databases. This enables organizations to continue to deliver reliably fast user experiences with a predictable return on investment for adding resources. Again, without the overhead associated with manual sharding. NoSQL databases are generally designed to ensure high availability and avoid the complexity that comes with a typical RDBMS architecture that relies on primary and secondary nodes. Some distributed NoSQL databases use a masterless architecture that automatically distributes data equally among multiple resources so that the application remains available for both read and write operations even when one node fails. And global availability. By automatically replicating data across multiple servers or data centers or cloud resources, distributed NoSQL databases can minimize latency and ensure a consistent application experience wherever users are located. An added benefit is a significantly reduced database management burden from typically a typical RDBMS configuration, freeing operation teams to focus on other business priorities. Lastly, the flexible data modeling. So NoSQL offers the ability to implement flexible and fluid data models. Application developers can leverage the data types and query options that are most natural fit to the specific application use case, rather than those that fit the database schema. The result is a simpler interaction between the application and the database and faster, more agile development. So there's a lot of different NoSQL databases out there that are free to use, and you can simply install them with your npm install. In this subject, we'll be using the MongoDB. So it's the most used NoSQL database. It's highly scalable and agile. This open source database written in C++ comes with storage that is document orientated. It has benefits provided to us of using full index support, high availability across WANs and LANs, and has easy replication and horizontal scaling. So if you're wanting to find out more about a range of NoSQL databases, here's a list of links that you could go and look at. So there's a range of different NoSQL databases you can go and have a look at for more information if you want to. We'll be using MongoDB for our work in this subject. So the next thing is, how do we install Mongo? So depending on your platform, whether you're running Mac or Windows, we have some simple instructions here for installing that. Installing MongoDB will install both a server software for the database, it will also install a client-side terminal application that we can use to query and look at our particular database.